Hey, what's up? It's Madeline from your class, your student. And for my project, I decided to do a video with a little bit of drawings in it, so, it'll be kind of interesting. Even though my voice will be voiced throughout the whole thing, I think it would be, interesting. Anyways, bonding over Thanksgiving. Just a little disclaimer thingy. My answers may not all be right. I tried my best from my personal knowledge and from research, so if it's wrong, I'm really sorry. Just wanna put that out there. Anyways, get back into the actual thing. Let's start with ionic bonds. For my ionic bond, I decided to choose salt, which was one of the examples. I'm sorry. An ionic bond is a chemical link between two atoms, and here is the salt. Yes, behold, yummy, delicious salt. Ow. Is it soluble in water? Yes. I bet you're wondering why, huh? Well, just hang in tight because I'm about to explain. The reason salt, or NaCl, the chemistry term, is soluble in water is, well, it can be easily dissolved in water. I mean, it's an easy answer, I know. Positive parts of H2O molecules, yes, I went all scientific on you, attract with negative chloride ions, and the negative part of the H2O molecules attract to the positive ions of the sodium. If that makes any sense. Melting boiling point. Well, if we're talking about melting, it would be approximately 801 degrees Celsius, and the boiling point would be around 1,413 degrees Celsius. Now that's hot, and I know hot. Anyway, I believe it is affected by its bond type due to it being ionic. Ionic bonds or compounds are known to have high melting boiling points. Fun fact. Gonna turn this page. Naturally or artificially occurring. I mean, from what I know, it's naturally occurring. You can't exactly make salt. Okay, the purpose of the compound in my dinner? Flavor, taste, But seriously, without salt, everything would taste incredibly bland and gross. Gordon Ramsay would be quaking. Okay. Moving on to polar covalent bonds. For my polar covalent, I decided to use sugar. Yes, one of the examples once again. Let's go. A polar covalent bond is a bond between two atoms where the electrons forming the bond are unequally distributed. Kind of like that worksheet we did a couple of weeks ago, I think. Maybe. You don't remember? Maybe. Okay. Behold, sugar. Much like salt, kind of looks like crystals. Keep that in mind. Crystals are beautiful. Okay, now, of course, sugar is soluble in water. The presence of OH groups in the structure of sugar allow these molecules to interact with polar molecules through hydrogen bonding. That results in, guess what? A high solubility of the compound. So keep in mind, lots of strong intermolecular forces to water means it dissolves well in water. Moving on to the hot question, does sugar have a melting boiling point? If you made a numeric guess, chances are it's wrong! Sugar can't melt or boil. It decomposes. I was honestly surprised when I was doing my research, not gonna lie. In any case, there's no real fixed answer for that. Sugar can't exactly melt. I don't believe that it's affected by its bond type. There are plenty of other polar covalent bonds that have melting and boiling points, so I don't think the bond type is the reason behind sugar being unable to melt or boil. So, sugar, like salt, is naturally occurring. Yes, there are artificial sugars out there, but it's, artificial. The real sugar is natural. So do I even need to explain, purpose of sugar in my dinner? Desserts! Come on now, without sugar, none of those delicious cakes or chocolate goodies would exist. I'm getting hungry. Okay, so, paper flip. Last but not least, nonpolar covalent bonds. For my nonpolar covalent bond, I decided to use, drumroll please, oil. Yes. And here is a beautiful picture of this greasy liquid. Ugh. Oh, crap. I'm sorry. I forgot to get a definition for that. Oh, well. Ow. Now, oil. Oil is slightly, or rather a lot different than the last two ingredients we spoke about. Oil is nonpolar and not soluble in water. Oil is nonpolar and is not attracted to water, so it will, unfortunately, not dissolve. Side note, keep in mind that polar molecules are like water, attract other polar molecules, but they do not attract nonpolar molecules, like oil. Now, the melting boiling point of oil all depends on how pure the oil is. If we're talking regular plain old corn oil, the boiling point would be around 475 degrees Fahrenheit or 246 degrees Celsius. Amazing how grease works. Is the boiling point affected by its bond type? I would think so. Maybe. Okay, so for oil, it all depends, honestly, if it's naturally occurring or artificial, If it's dug up out of the ground, it's natural. If it's car oil or something like that, then I'm afraid it's artificial. Oops. Purpose of this compound in your dinner? Well, other than it being a fatty liquid, with lots of calories, it's useful for frying, like fried chicken. Delicioso. Alright, now, time to move on to our big number. Conclusion questions. So, for our conclusion questions, we have A. How does soap help clean the dishes after dinner? B. Cling film is commonly used to cover leftovers. What property of cling film allows the plastic to stick to surfaces and itself? C. How would your Thanksgiving dinner change if each compound had the opposite solubility in water? And D. Compare the metal in the heating element of an oven to the aluminum foil that covers the turkey. What type of bonding occurs in each? Now, you see, to avoid getting anything wrong, furthermore, I thought it would be better if we went over it as a class, because teamwork makes the dream work. So, I would take this time now, if you want to pause the video, to, discuss among classmates. Yeah, so we can better understand it all together. So if you want to pause now, go ahead and do it. If not, then this will be the end of my video. So, yeah, I tried my best. Appreciate you guys watching and stuff. So, yeah, keep in mind, chemistry rocks. And, stay curious, guys. I totally did not steal that from the Amoeba Sisters. Okay, seriously, bye.